Dr. Ben Goertzel is the CEO of the Decentralized AI network Singularity Net, a blockchain-based AI platform company. He's also a chief science advisor for Hanson Robotics, where he spent several years leading a team developing AI software for the Sophia robot. Dr. Goertzel serves as the chairman of Artificial and General Intelligence Society, the OpenCog Foundation, the Decentralized AI Alliance, and the futurist nonprofit Humanity Plus. He's also one of the world's foremost experts in artificial general intelligence, a subfield of AI oriented towards creative thinking mixed to take it a level and beyond. He spent several decades as an expert solving problems in areas from natural language processing and data mining to robotics, video gaming, national security, and bioinformatics. He has 20 scientific books and over 140 scientific research papers published. And as the main architect and designer for the OpenCog system, he's been associated with much human-level general intelligence. Quite a biography. So his topic today, Ben's topic, is AGI via decentralized, self-organizing, evolutionary, neural-symbolic learning. So over to you, Ben, and very good morning to you.
Good morning. It's just barely morning here on the U.S. West Coast. It's 12 a.m. So it is the end rather than the beginning of my day, but it's it's a wonderful end to what's been a good day so far. So yeah, it's great to be part of the Wonderland AI Summit. Unfortunate not to be part of it face to face, which is even more fun. But I mean, it's amazing we have these technologies to let this happen at long distance, right?
Yeah,
so
exactly.
yeah, and I guess this decentralized conference is somehow appropriate for a talk on decentralized intelligence. I mean, the conference in itself is a form of decentralized intelligence, right? So
exactly.
So I'm gonna cover a lot of ground in a half-hour talk here, and try to go from sort of basic concepts of artificial general intelligence and the algorithms underlying it to, you know, the cutting edge of where we are today with the AGI and decentralized implementation. You know, what I see for the future in terms of taking more and more steps toward general intelligence using decentralized technologies. So let's start off on the AI side of things before moving into decentralization, which is another big theme. So a long time, it's picked up speed in the last few years due to advances in you know, computing technology and availability of data and so forth. I think we're now in the midst of what's going to be the first of several waves of radical AI advance. So we're in the midst of what I'd call the narrow AI revolution, where we're seeing AIs that can do highly specific things very well, you know, become incredibly useful and effective in relevant domains. So, I mean, one after another job that traditional humans have done is being taken over by AIs, and I think this is just going to increase. And you know, we're going to see a lot of the jobs that are going away now due to the COVID pandemic. They're not all going to come back, right? I mean, I know you said we're not supposed to talk about politics, but I can't help putting a few comments in here, right? I mean, a lot of the jobs aren't coming back because while people are stuck at home suffering from COVID or hiding from COVID, like the AIs are being put in their place, and in some cases, automation will do things better than. But this is just the beginning, right? I mean, the next step is going to be the artificial general intelligence revolution, which is where we're going to see AIs that aren't just carrying out highly specific functions, but you're going to have AIs that are able to understand the whole coordinated complex system and orchestrate narrow AIs and other narrow automated systems doing highly specific things. So say right now, what's called a smart city is really a few isolated smart functions doing, say, traffic regulation or smart power management. And these smart functions are networked together within a not very smart or adaptive overall IT infrastructure. And a real smart city would have a coordinating general intelligent brain for the whole city, coordinating together like the traffic narrow AIs and the power management narrow AIs and the healthcare and narrow AIs and so forth. And of course, now in just interacting with the internet every day, we use all sorts of AIs, like one that recommends music, one that does search, one that tries to give voice control to our phone, but these have no understanding of what each other are doing. There's not like an overarching intelligent assistant governing all of our internet interactions. Things like Google Assistant and Siri are very far from that now, right? So again, this is mostly because we just don't have the AI algorithms and structures now to understand context and to bridge gaps between different narrow domains. And I think that's going to happen in the next 5 years. We're going to verge into the AGI revolution, building on all the tools and successes of the narrow AI revolution. And I mean, that will bring us amazingly far. I think super intelligence comes after that, the move from AGI to ASI, artificial super intelligence, where you get into the singularity and minds that are vastly more intelligent than we can even comprehend. I've written a lot about that before. What I want to focus on today is a little closer to home than that. So we have narrow AI revolution, AGI revolution, ASI revolution, and singularity. But between, which is what we're entering into now, and you can have what I think of as narrow AGIs in there, which are systems that demonstrate more and more general intelligence step by step, but their intelligence is mostly focused in some particular area, while it's in the process of broadening. So I mean, you could have a narrow AGI for a smart city and a narrow AGI for, say, medical robotics or something, which is gaining more and more ability to understand context and transfer knowledge, working toward general intelligence bit by bit. And I think the most exciting applications in the next few years are going to be those that take application-specific collections of narrow AI tools and connect them together and imbue them with gradually increasing levels of general intelligence, which is narrow different types of algorithms that continue to be good, and it's going to expand to things like video processing that haven't been done so much yet because of compute power constraints. I think some of the other AI paradigms that have been there historically in the AI field are they're gonna sort of rise to the occasion and alongside neural networks push AI forward in the next stages. So symbolic AI, got a bad rap because in the 70s and 80s, under the guise of GoFi, good old-fashioned AI systems, symbolic reasoning-based AI systems were often used based on like hand-coded knowledge bases. You have projects like Psych, where just all these people are typing in huge amounts of logical relations trying to represent common sense knowledge, and then they're reasoned on symbolically. But I think you can have this symbolic reasoning and the abstract knowledge representation that comes with logic-based AI systems on also learning, experiential learning, reinforcement learning, supervised learning. I mean, you can have logic-based systems that learn just like neural nets learn, and often better than neural nets learn. So the historical association between expert, like hand-coded rule bases and logic systems, I think was sort of a matter of accident. And we're going to see symbolic reasoning systems connected to the world in a learning-based way, and hybridized with neural nets in neural-symbolic systems in interesting ways. And we're also, I think, going to see a resurgence of evolutionary algorithms and genetics algorithms, genetic programming, evolution strategies. And these algorithms have a real strength in the area of creativity. I mean, neural nets are fantastic, but if you look at something like Google Deep Dream, on the one hand, it's really cool, the generative things it comes up with, and what GPT-3 spits out in terms of bloviating text productions, really cool. On the other hand, they're pretty transparently just recombining what was fed into them at a pretty atomic level. Like they're not coming up with any radical fundamental creativity. Now, most of what us humans do isn't all that creative either, but some of it is, right? And I think evolutionary algorithms capture that radical creativity that humans or evolving biological systems can evince at times. Now, if you can put together, neural networks with their capability to recognize patterns in huge data streams and data sets, with symbolic AI systems with their ability to encapsulate huge amounts of knowledge in small formulas and manipulate them via inference, and put that together with evolutionary algorithms with their ability for radical creativity. If you can put all these together, well, you're getting somewhere close to an AGI mind, right? And you could approach this in a number of different ways. I mean, you could try, and here we get into architectures rather than algorithms, right? So I've looked at neural, symbolic, and evolutionary algorithms. If we want to get all these things together to get more of a fully featured artificial mind that is moving from neural AI toward AGI, we can embed that in a variety of different architectures. I mean, you can try to emulate the brain's architecture, which is what a number of teams within Google DeepMind are doing. I mean, along with other things that they're doing, where you look at the human brain, has many different regions, many different subnetworks. Some of them are doing more like neural Darwinism, evolutionary learning. Some of them are doing more abstraction. Cerebellum is doing sequential planning. So you can look at the way a brain breaks down human-like cognition into different functions and try to emulate that. You can take a more cognitive science view, which is what's been done in classical systems like SOAR, ACT-R, and so forth, which are cognitive architectures. They ignore the brain, but they look at how does the human mind, as studied by cognitive psychology, break things down into different processes like declarative reading, reasoning, episodic memory, sensory processing, planning, and so forth. You can take a body-driven approach. I mean, that's somewhat what David Hansen and I did in our work with the Sophia robot, where the robot sensors and actuators and its social and emotional relations, they drive the whole architecture, and then it's learning from its embodied experience. Marvin Minsky, AI pioneer, had the notion of a society of mind, where you view an AI mind as made up of a whole bunch of different AI agents, and the AI agents each have their own measure of intelligence, but most of the intelligence is from the multiple AI agents, collaborating and cooperating together with each other. And this ties in with my work on Singularity that I'll get to in a few minutes. And my friend Weaver, David Weinbaum, has a beautiful PhD thesis from Free University of Brussels with the title Open-Ended Intelligence. And he's looking at a different model of intelligence, which is just a complex self-organizing system that recognizes patterns in itself and the world around it, and is fundamentally rewriting and revising everything in its architecture. So there's a lot of ways to combine the various sorts of algorithms involved in the mind into an overall architecture. And it's not clear that any one of them is the one right one, right? So the path from narrow AI to AGI may involve some brain-like approaches, some more cognitive architecture approaches, some embodied robotic-based approaches, some society of mind approaches. I mean, just like we have airplanes, helicopters, blimps, and rockets, a whole bunch of different kinds of flying machines, different strengths and weaknesses, all operating according to the same underlying principles of of aerodynamics, right? So I want to talk next about briefly two particular systems I'm working on, which connect with each other, which are both aimed at making this leap from narrow AI to AGI through narrow AGI application. So one is the OpenCog system, which is an open source AGI oriented project. It's been around for a decade plus. We're radically rebuilding OpenCog with a new version called OpenCog Hyperon, and we have a new company called True AGI, which is spun off from our Singularity Net AI blockchain project that I'll tell you about in a few minutes. True AGI is building some, proprietary application tools for controlling robots and devices using OpenCog Hyperon, new version of OpenCog. And the basic idea here is you have a common knowledge hypergraph, the Adam space, a weighted labeled hypergraph that represents all different kinds of knowledge, like declarative, procedural, episodic, sensory. And you have a number of different AI algorithms, say a logical reasoning engine, a number of different neural networks, evolutionary algorithms, associative attention allocation algorithms. They're operating together concurrently, updating this knowledge hypergraph, right? So that's what in the ancient days would have been called like a blackboard architecture. We have a blackboard that multiple guys are all writing on the blackboard and adding on to what each other wrote and erasing things that each other wrote. But here the blackboard is this distributed knowledge hypergraph, and the AI algorithms are doing things, from all different AI paradigms. The subtlety in this kind of design is the different AI algorithms have to not screw with each other, but rather help each other, right? So like if the logical inference engine gets stuck, then a neural net may help it get unstuck. And the things that an evolutionary algorithm is evolving, well, that won't be useful if the logic engine is just undoing them immediately, right? So you need cognitive synergy among the different AI algorithms cooperating, and this is what we're building in OpenCog Hyperon. I think we've done a lot of work with OpenCog in the last decade that's taught us a lot, and now we need to massively scale it up so we can run this sort of multi-paradigm knowledge graph based AI on the same scale that you can run a transformer neural network or a CNN. And that's what we're aiming at with the OpenCog Hyperon system we're building in the True AGI project. And one of the tools we're using for this implementation is something that also has far broader applicability, which is the Singularity Net blockchain-based AI platform. And this is more along the lines of Marvin Minsky's Society of Minds. It's like if you have a bunch of different AI agents and they need to coordinate together, how do you manage this coordination in a way that doesn't have any central controller, but it's just a self-organizing system of different AI agents operating together? Now, this helps with OpenCog Hyperon, where we have multiple different AI agents acting on the same knowledge hypergraph. It also works with a system of a bunch of AI agents that don't share a common representation, say a neural net that's just piping some patterns into a logic engine, which is cooperating with an evolutionary learning system to answer someone's query, but they're each sort of separately encapsulated agents. So whether to do a distributed implementation of something like OpenCog Hyperon, or whether just to allow different AIs coded by 1,000 different programmers all over the world to cooperate with each other and form ensembles to help solve problems. What we wanted with SingularityNet was a decentralized platform where all these different AI agents could outsource work to each other, cooperate together to answer user queries and get paid for the things they're doing, but without having any single platform or any single controlling entity underlying all these. And I mean, that's where blockchain comes in, because blockchain lets a bunch of different software entities coordinate together in a decentralized way. And I think that's important for a number of different reasons. I mean, for pure computational efficiency, it's easier to get things efficient in a centralized architecture. But in terms of the practical economics and social organization of the AI space, I mean, if you can get a society of minds where the different parts can be owned by different people and different entities, and have some autonomy in controlling how they're operating rather than running within someone's walled garden. I think there's the potential for much more diversity of architecture and function in the different AIs in the network, which will then foster greater emergent intelligence in the whole society. And I think this can be a different path than the big tech company centric mode of AI development that we're seeing now, where so much brilliant AI is inside the the locked up server farms of a Google, Facebook, a Microsoft, a Tencent, a Yandex, and so forth. And I mean, it doesn't really have to be like that. You don't need that central entity. You can just have a bunch of AI agents. Some are neural nets, some are logic engines, some are some new thing you never heard of, and they're cooperating and collaborating together just on the internet, right? And I mean, this it's harder in some ways than making things centralized, but I think the internet is a decentralized system which has been incredibly powerful because of its decentralization, and I think that can be the same way for this sort of decentralized AI platform like Singularity Net. So to make these ideas a little more concrete, I want to take the last few minutes of this talk to see like how do they cash out in some specific applications that I've been working on. So let's take an example of a project I've been spending a lot of time on lately. It's not officially launched yet, but I'll hint at it a bit here. So I'm working on something quite interesting in the area of medical and elder care robotics. So we're looking at collaboration with folks from the robotics space and the medical space to create, very sophisticated robots which will interact with the elderly people and patients in the hospital or nursing home setting. And I mean, here, this really, to do this well, requires more general intelligence than current hospital or nursing home robots have. Like the systems that are in place now for this sort of purpose don't have any episodic long-term memory. Like they're not understanding what happened last week or last month to the patients that they're talking to, and they're not able to adapt what they say and do to the needs and personality of the patient at hand. And this really limits them to serving a fairly small subordinate function, right? So I mean, if you want an AI that operates a robot in a healthcare context that is able to adapt to the personal needs of the individuals it's interacting with, you end up needing a fair bit of sophistication, right? And so you can see, so we have a role for perception and neural networks, definitely. Like we need face recognition, we need speech recognition, we need recognition of patterns of movement of different people and so forth. So there's a big role for neural systems for sensory processing. On the other hand, in coming to our understanding of the semantics of what a person is saying and what the needs are at a time, you find the need for more abstract representation. And if you think about like GPT-3 or something, you can't use that as a dialogue system for a medical service robot, because like 10% of what it says is utter gibberish, and sometimes inappropriate gibberish, right? And that's okay if you're making like funny essays or something, or making an entertainment robot. But if you're making something that's trying to serve serious functions in a medical context, it's not okay if 10% is random gibberish, right? So why is it random gibberish? Well, because these transformer neural nets like GPT-3 have no idea what the hell they're talking about. Like they have no semantic model of what they're saying. So they're saying things on the surface seem like they make sense, and often do, but don't always, right? So we need a semantic model of the domains so that, you know, when the robot is talking to an old person, it knows they're old, and it knows what old means, and it knows that means they lived a long time and may not live much longer. It knows that generally old people move more slowly than young people. I mean, old isn't just a word; it's grounded in a bunch of knowledge about what old things are like, right? And so that semantics is needed to make the dialogue appropriate enough to actually be rolled out in that context. Now, creativity, as we get from, say, evolutionary learning algorithms, I mean, you might think it's not key in this space, but actually, you know, a lot of people in the elder care hospital context are just very bored, and mental stimulation and novelty and excitement, fun. I mean, this is just as important as straightforward medical care. And so, I mean, a system that is completely logical and understands the semantics of what you're saying, but has no sense of creativity or fun or play or spontaneity, that's not actually as good for your health as a system that's more creative in stimulating you. I mean, yeah, you can have an AI system that points out video games to play on a tablet to an elderly person in the elder care facility, but if the dialogue itself is playful, creative, and fun, and say reminding the person of interesting episodes in their history and asking them, well, what would have happened if life had gone this way instead of that way, right? I mean, you have a role for creative invention and spontaneity, which comes from evolutionary learning here, and then you have a sort of body-driven cognitive architecture where you have AI that controls the robot body, AI that controls perception, AI that controls language. But then on the back end, you can have a society of mind-driven cognitive architecture, because some of the mind of that robot can be embodied in that robot, and some of it can be in the cloud. It can be in the Singularity network with many different AI agents distributed all over that are pulled in on an ad hoc basis to help the robot and answer different things. So that if say the robot is talking to an elderly person who starts talking about their childhood in Soviet Russia or something, I mean, then, you know, the AI may not know that, but there may be some other AI that's really good at interpreting historical texts and can provide some context. So yeah, we can see in this example application how multiple different AI paradigms in a cognitive architecture that combines an embodied aspect with a distributed, decentralized society of mind aspect. All these things can come together, and you can get a system that, while initially it may not have the general intelligence that you or I have, it's gradually moving in that direction in a way that allows it to deliver, you know, differentially superior functionality to pure narrow AI systems in this domain. And so this is one particular example of sort of hybrid AI algorithmics, combining AI algorithms from different paradigms within a fairly subtle cognitive architecture intended to move from narrow AI toward AGI by delivering increasingly generally intelligent functionality in the specific application domain. And yeah, this is something I've been working on a bunch lately, and we're going to announce this product within the next week or so. But, you know, I could have talked about our work in, say, clinical trial analysis and bioinformatics, trying to understand the roots of human disease, or our work in decentralized finance and risk management, or smart cities. Like you can pick any domain you want. The same basic algorithms apply, variations on the architecture are there. But I think across every vertical market, we're going to see this pattern: narrow AI to AGI through integrating AIs from different paradigms within cognitive architectures. And
Okay.
thanks
Wow.
for listening.
No, I've got a couple of questions actually.
All right.
So thanks very much for the couple of questions, all of which we'll attempt to manage in the next 5 minutes. But stimulating, extremely interesting, Ben, not just from the comments on society of mind and this sort of extraction of AI out of verticals into this pattern, true pattern right across the board. I mean, it sounds fantastic. Very curious on what you've mentioned on the creativity, the role of creativity in the medical and robotic area for the elderly scenarios that you described sounds very interesting. We'll be following very closely to see what this exciting news is in the coming week. If you decide that you want to exclusively mention it later, you're more than welcome to get up after your night's sleep and come back and announce it here. We'd be more than happy to allow you that platform, but we'll be following most closely. A couple of questions. I'm going to call them out quickly, and then you can sort of either blend them or deal with them one by one. How do you imagine the future world in 50 years from now? Okay.
Well, I think we're going to get a technological singularity well before 50 years from now. So
Right.
there will be superhuman AGI minds, and you will have the opportunity to either merge with them and become something radically transhuman,
Exactly. Yeah.
or live on happily forever in the national park with the other squirrels and bunnies and humans, watched over by the super AIs of loving grace.
I suspect we'll all be. It won't be that far away. Exactly. A very a good one from Emin. Thank you, Emin. Do you support Alan Turing's test as a determination for real intelligent system, as being a computer would deserve to be called intelligent if it could deceive a human into believing it was human? Would you agree with that?
I don't think the word intelligent is tremendously well defined or even necessarily an important concept, but I think the spirit of that question, I would say no to. Like, I think that you could make a system that would fool almost anyone into thinking it was a human, but that
Okay.
system could still have a very low level of general intelligence compared to a human. And I think
Yeah.
that Turing might think the same if he was alive today. Like, I think
Yeah.
he wasn't
Fair point.
thinking about transformer neural nets, and just he
Yeah.
wasn't thinking that you could make such huge
Yeah.
data sets and then make such huge catalogs of
Yeah.
syntactic patterns
Question
in
is
those data
oversimplistic,
sets.
perhaps. But very good response. A couple of quick ones because I want to make sure we get each of them on the table for you, Ben.
All
Do you
right.
think active learning? Do you think active learning can help us get closer to making AGI?
Yeah, very, 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 very important concept. Absolutely. Yeah. I mean, perception, action, and cognition they're all wrapped up in multiple feedback cycles.
You okay? And then Marco asks, any ideas on strategies decentralized AI could use to cope with contradicting information coming from diverse sources?
I mean, I think at this point, the best way to cope with contradicting information in decentralized networks is still via human judgment. I mean, what we really need are reputation systems that allow multiple people to rate items and to rate each other's ratings of items in a decentralized way. And we've done some work on that in Singularity Net. And the role of AI there is a bit subtler. It's to identify patterns of reputation and rating fraud.
Yeah.
And it's more like a reputation cybersecurity role for AI. I think, of course,
Yeah.
once you have human level AGI, the AGI can just check what's true or what's false. But right now, our AIs are not intelligent enough to really identify what's false versus just true
Yeah.
but unexpected
Very good.
information.
Yeah. And then my final question, Ben, because I want to try and keep to time, and I want to thank you also very, very much. I mean, we'll be following very closely. Final question is perhaps a big one, so I'll see how you answer it. Will it be possible to build artificial emotional intelligence?
Yes. You want a short answer, right? Yeah, I
Yeah,
mean,
that was a very short answer.
I mean, emotion has two aspects, right? There's what's called the hot and cold aspect. So the cold aspect is the structure of an emotion, sort of the expectations that were satisfied or frustrated. And that's really an information theoretic thing, studied well in cognitive psychology. No reason an AI can't have it. The hot aspect is the conscious experience of an emotion.
Yeah.
And there you're really into the qualia problem, like
Yeah.
philosophy, like can
Exactly.
a digital computer have qualia? I'm giving 10-1 odds, yes, but to tell for sure, I got to wire my brain into the computer and see if I can feel it there on the fringe of my consciousness through the wire from my head into the realm of the machine. Right?
Fascinating, that thin film of consciousness over the mind and the machine, as you might say. Ben, thank you.
It's not over. Consciousness is imminent in everything. So it's not a film over. It's just a property that's refused throughout, I think. But that would be a whole other talk and a whole other conversation. So.
Yeah, very, very well put. Thank you so much, Ben. I know it's been very late for you there on the West Coast. I hope things improve on all fronts. And well, I hope you get a good night's sleep if you're going to get your rest. Thank you very much, Ben Goertzel, Dr. Ben. And
all right. Yeah. Thanks for having me. I think I'm not going to go to sleep. I'm gonna program some AI and get us closer to the singularity here. But
wow,
but this has been good fun, and hopefully I can join you in person next year.
Thank you very much. Okay, Ben. Well, good night and good luck, and keep in touch.
Bye-bye.
We'll see you in person again. Thank you. Thank you very much, Dr. Ben Goertzel.